In the field of computer science theory, computer science theorists think carefully about what is the best possible algorithm from an asymptotic point of view. And they're not really necessarily concerned with the practical implications. They're trying to push the frontiers of mathematical knowledge. And sometimes you get a practical implication out of it, sometimes you don't. Well, mathematically inclined computer scientists have been looking at the minimum spanning tree problem for a long time. Actually, Prim's algorithm is from way back, like the 30s. And then Kruskal's algorithm, it's sometime in the 50s. And since those early days, computer scientists have tried to come up with more clever ways. And so here is a timeline, and this is based on a slide from Kevin Wayne at Princeton, who I mentioned earlier, as someone I worked with. And so if you look at the history of minimum spanning tree algorithms, in 1975, the best algorithm at that time was E log V, under certain constraints not listed here, and that was the state of the art. Now in 84, an E log star V algorithm was invented that is similar to what we've been talking about today. In 86, this was improved to be E log star V. So you get a little faster, right? Like the log of log star V is better. Now again, on a practical basis, remember this function is basically 5 and no larger ever. And so log of 5 is not going to be that different, but hey, okay, whatever. Now in 97, there was an even better algorithm discovered, which was E inverse Ackermann function of V times the log of the inverse Ackermann function V, where this is even slower growing than log star. And in 2000, this was reduced, so we got rid of this pesky log inverse Ackermann function factor, and it was just E inverse Ackermann V. Now in 2002, a really interesting thing happened, where a couple of folks discovered an algorithm that was guaranteed to be optimal, but nobody knows the runtime. So maybe it's E, maybe it's not, nobody knows, but it's known to be the best possible asymptotic runtime. And if you're curious about how that's even possible, it's a kind of a surprising fact, you can check out this link and read a little more about it. And so maybe at some point in the future, someone will prove that this algorithm is E, or they'll find another different algorithm that is provably E. But it's unknown whether or not it could be done in E time, or if you need just a tiny bit more time than E time. All right, so that's it for this little taste of theory. That's it for this lecture. See you next time.